Hi everyone, today I want to solve a tank question. At this question, component A and component B pouring at the tank. They mixed together actually, maybe we have a kind of mixer. And they evacuated with a pump. Being there is a pump is important because if there is a valve, let's draw like this. The flow rate won't be constant. I mean, it will be related to the BF related to GH, maybe 2GH. I mean, 2GH. So that there will be a pump is important. The question says the constant density is also important. In this question, we can write three component balance because there's a three component. Three balance. First, total balance. Total balance. Balance A. And then balance C. Let's start with the total mass balance. Overall mass balance, maybe. Overall mass balance around the system. Let's start with the flow rate A and the density plus B. Actually it's 0. The question says, but I will write 0 and then flow rate F times density is equal, input minus output equal accumulation. The accumulation is about the height. Let's write with the derivative of A. A is the surface area, let's write there. Surface area. A times height Z times density again with derivative of time. You can write this then let's write negative minus flow rate F times equal constant A and constant derivative of A with respect to time. Then what will happen? Flow rate A minus flow rate F equal A times derivative Z. I make mistake. Derivative Z with respect to time. Then we can write derivative Z or derivative time is equal V times and F over A. It's our first relation. Then what will happen? We take both parts, so integrate. Then we will achieve the Z with respect to time. We need Vt equal what? Let's write V times T equal flow rate A minus flow rate F divided by A times T plus C. Comes from the integration both part. How will we find C in here? We need a boundary condition. Boundary condition 1. Boundary condition 1, what should be? It's the at time 0, at time t equals 0, or height, tank height, actual mixer height in the tank is equal the initial right. If we take 0 to this function, this part will go and the only c part is coming. Then we have this equation a ef times e to t plus e0. This is our second relation. Hi everyone, today I want to solve a tank question. At this question, component A and component B pouring at the tank. They mixed together, actually. Maybe we have a kind of mixer. And they evacuated with a pump. Being there is a pump is important because if there is a valve, let's draw like this. The flow rate won't be constant. I mean, it will be related to the BF related to G hash, maybe 2G hash. I mean 2G hash. So that there will be a pump is important. The question says the constant density is also important. In this question, we can write 3 component balance because there's a 3 component. 3 balance. First, total balance. Total balance. Balance A. And then balance C. Let's start with the total mass balance. Overall mass balance, maybe. Okay, then let's continue with material balance around C. Material balance C. How can we write? Let's check. This part brings nothing. 0 minus consumption. There's no consumption. Plus generation. How can we write generation with reaction constant? Oh, there should be a reaction constant. Lowercase k. How can we write then? Let's write Q1. Actually, Q1 CAF times A times C minus the output VF times CCF. Equal accumulation. I can write accumulation like the same with others. A times Z times CCF with respect to time. Let's get simple it with just write the same thing maybe. Let me first write this because input minus output plus generation, consumption, etc. Then let's first write this. Flow rate F times CCF plus K1 CAF A times Z equal A times A is a constant Z times derivative CF with respect to time plus A times Z times A times CCF times derivative Z with respect to time. Because of we don't know the CAF, that part brings nothing at this time. We should continue next time, maybe. Let's continue with material balance A. Material balance A. Material balance A, how can we write? Like other, we can write VA times C A0 minus VF C AF plus let's write this. Let's write with this VA times V. V is the volume at the mixture in the tank, and it's equal D times V times the accumulation. How can we write? CAF over DT. Okay, yeah, we can write with it with this. Then what it brings us? VA times CA0 minus VF CAF minus K1 CAF times A times Z. Z is the function of the height with respect to time. I mean, this is Z equals Z. I just want to write with this. Let's continue. Equal accumulation. It's same. We can write with this. A times Z times dCCCAF over dt plus A times CAF times derivative height with respect to time. Okay, how we will continue. We will continue with it brings us a ODE. We need to reach the ODE. How can we reach? We can reach with we need this part alone so that we can divide both parts with AZ. Okay, then let's divide both parts with AZ. VA times CA0 minus K1. No. Divided by AZ. Okay, then let's continue with material balance around C. Material balance C. How can we write? Let's check. This part brings nothing. 0 minus consumption. There's no consumption plus generation. How can we write generation with reaction constants? There should be a reaction constant. Lowercase k. How can we write then? Let's write Q1. Actually, Q1 CAF times A times C minus the output VF times CCF. Equal accumulation. I can write accumulation like the same with others. A times Z times CCF with respect to time. Let's get simple it with Just write the same thing, maybe. Let me first. Now we can obtain the ODE with making this part alone. Let's write d CAF over dt equal CAF times, let's write, there's no CAF, flow rate F minus K1A times Z minus this part A times Z over 0T divided by AZ plus VA or CA 0. Okay, that's good. Now we have this equal PT times Y plus QT. We need an integration factor. Let's write integration factor as mu equal E exponential, let's write integration of pt dt is like s, but it's an integration. Okay, with respect to t, then we need to solve integration factor mu times y equal of mu times qt with respect to dt. Maybe we can continue with the Python. But before move to the Python, I want to simplify this part because we know the derivative of z with respect to t and z. Let's write with this pt equal minus f a times z. Let's write z with this z0 times a, z0 times a times z0 plus flow rate a minus flow rate f times t. Okay, and minus k1 minus we need to divide this too. How can we divide? Let's write with this VA minus VF divided by AZ0 plus but there is no, that's true. VA times VF times T. Okay. And we have a QT. QT means equals VA. So VA, I mean, need to divide this part to AZ. VA CA 0 times AZ. It's equal VA CA 0 divided by a times c, c0a plus a0. No, there's no zeros here because they are constant. Let's correct it. xvf times t. Okay, that's correct. Let's solve the question.
Hi everyone. Let's continue with solving ODE with using SymPy in Python. First, we import our library. Import SymPy as baby. Then our symbols. Let's hashtag. Cool. CP dot symbol. No. Yep, it's okay. The as the CP dot function. The AF with respect to tree, we will define it. Oh, okay. Okay, that's okay. Let's continue with our constants, like actually it's our derivatives, not constant, but I labeling as a constant. We have VA, VF. I want like to lowercase V0, K1, K1, CA0, and A. CP dot symbols. No, it's yeah, wrong. Well, done right. Same thing without commas. That's okay. Let's say positive. Positive. Oh, what can I? Oh, that's interesting. I will explain later this part. We have common terms. I mean, let's say it's a common term. Common. That's right, as ban. A minus VF times T plus, no, yes, yes, times T plus A times V0, V0, yes, that's exactly. Also, can write for Qt and PT. That's Qt. Oh, Okay. Let's write first the PT. Or QT first. Let's QT is, oh no, just I want to write QT. Yes. VA times CA0 respective then. Okay. Should be true and PT is equal minus VF VF over then. Yeah. Let's write this down. Minus K1 minus VA0 VA minus VF over D over that. Okay, let's continue with solving the integration. Let's write the integration function is mu. Integration. Integration constant. Mu. You remember mu t. That's right. Mu t is equal CP exponential CP integrate. Let's say integrate. Second one. PT times PT with respect to t time. Okay, your mu t is ready. Let's say general solution. Oh, I made a mistake. Okay, general solution. Right. Integration part first, let's say. Integrate part as called CP dot integrate mu t times qt qt with respect to t. Okay, that's yep. This is our integrate part. Let's see the constants, integrate constants coming from integration. CP dot symbol symbol. Okay. Let's uppercase C, let's say. And then the general solution. So, solution. C, F, let's say general. General is the code integration parts. Integration parts plus C. Okay. And then you can write CP dot CP. Print. Let's print this now one time. CAF general. Let's make this uppercase. CAF. No. Okay. CAF general. Now let's simplify. You cannot write P5. I think I write correctly, but I will check later if it doesn't work. Use Unicodes. Oh, sure. Okay. Okay. Okay, let's work. Environment. I will use. Oh, I will come back. Okay, I'm coming back. I downloaded the expansion packs and I run all the cells. I was forgetting the explaining this part and this part also. This means the real equal true. The t is always be a real number. I mean, doesn't supposed to be a imaginary number or something. The positive equal true mean these values are always positive. It cannot be negative. These expressions can help to SymPy making a prediction about the formulas. Then the Unicode equal true means if you can write this, the expression, the output will given at this form. I mean, with like latex form. I mean, okay. Then this is our general formula for CAF, but we need C also. How can we know C? We need a boundary condition. Okay, let's continue with the paperwork. I mean,
Our boundary condition is coming from the steady state situation. Let's write A balance at steady state. How can we write? We can write CAF steady state times VF plus CAF steady state times K1 times AZ, the volume, is equal the input, which is the VA CA0. Okay, then if we make a CAF steady state alone, CAF steady state is equal VA CA0 with respect to VF plus K1 AZ, which means Z is the Z0 at time t equals 0. Okay, it's our second boundary conditions. Condition 2.
okay, let's write C upper C is equal. I've also define CA F steady state is equal to VA minus VA 0 divided by VF plus K1 times A times V0 times E. Let's take integrate as so then C value is equal CP solve general. That's T on Z. Let's say minus the steady state. Maybe this solution finds a few output, then I want to take the first one. Let's say 0. Then we have absolute solution. Solution. CAF final. Let's say CAF final. It's the code CAF general plus. Let's say that's subs. Subs CAF. That's subs. C C value. Okay. Then CP at print. CP dot 35. CKF final. Wrinkle. Comma. Again, we say you use Unicode. Code true. Okay, let's run this. Says. We solve that. Let's make go through. He got CP prints. I some mistake about this. Okay. Yep. Let's write this. Okay. Okay, I just want to explain some things. And this part we say if you use 0 instead of t at the CAF general formula, we can obtain a CAF assessed CAF for steady state condition. Then we take its first parameter and CAF subs mean is applied. It instead of C, it's write C value. Then we simplify and print it. At our output, the integration doesn't apply it. But we do not need to evaluate it. It's enough for now. Let's continue with find CCF.
Lastly, to find CCF, we need the derivative of CCF with respect to time should be alone. And let's make it dCCF or dt is equal K1 CAF minus VF CCF or AC 0. No, AC 0, no, it's function. Z function. And minus CCF dz or dt. Or z. I divided both sides with az. Then let's write we can take parentheses dCCF CCF or dt equals CCF. Let's make minus CCF VF or AZ. Then minus VA minus VF with respect to time, and VA VF plus Z0A. It's come from there. I made a mistake. Actually, yeah, it's supposed to be plus because minus in there, and plus K1 CAF. Okay, and then we need again the integration constant. Integration function actually qt K1 CAF and PT equal VA minus VF divided by TVA minus VF plus Z0A plus VF with respect to AZ. Okay, then new T is the exponential integration of PT with respect to dt. Then let's divide here. CCF t is equal 1 over mu t integration of mu t times k1 CAF time dt plus c again, or maybe we don't write here because there's an integration, but let's write c, let's write it as a c2. Okay, and let's solve this part, but we need to write here as a minus sign. Equal minus